Welcome to GlassKey, an Android application that stores virtual keys, allowing you to unlock your everyday mechanisms with the use of NFC technology. When we look at everyday objects that people may need to unlock, some of the first things that come to mind are mailboxes. NFC technology can not only unlock objects, but do many other things as well, as shown in the graphic. A person can use NFC technology for secure ticketing, to log into their personal websites using passwords, make payments, and many other things. People use NFC technology every day already without knowing, like when they tap their phones to make a simple payment or unlock their car doors by simply touching their phone to their handle. With GlassKey, however, we aim to use NFC technology to allow a user to unlock everyday items, such as mailboxes. As Rutgers students, we constantly pass by the mailboxes on Bush campus as shown in the image. But these mailboxes, just like most mailboxes, require keys. With our solution, we aim to minimize the need for physical keys with a cell phone application and an NFC reader. In our application, GlassKey, we are able to hold multiple passwords that allow a user to unlock different things such as mailboxes, security safes, and any other secure items by simply tapping their phones. All a user has to do is store these passwords onto the application. We will now show you a working version of GlassKey to unlock a virtual mailbox.
Our product is composed of an all-in-one application called GlassKey to universally manage and store NFC keys that are user inputted. The first step would be to install this application on your Android smartphone that has NFC capabilities, of course. In our project, due to underlying circumstances, we're going to set up a mailbox simulation that was set up for demo purposes only, since the physical mailbox system could not be developed, as shown on the screen here. This simulation is terminal-based and is very similar to what the actual physical demo unit would have looked like, except in software form. We are going to showcase the physical system and how it would have worked later on in this video. Running a basic Java command on the simulation allows us to demo our original idea. The first thing we have to do is plug the NFC to USB reader in the desired machine, as shown here. We can then start running the simulation smoothly. The GlassKey application includes several features to make the all-in-one experience simple and easy. We have implemented a basic object system where the user is able to input a title-password combination that makes password management much easier. As you can see, adding a key element is as simple as typing in the title and password and then clicking on the Add button, where it is then able to be securely added to the list. The password, once added along with the title to the list, remains hidden from the user for security purposes. Once each pair is added to the list, the user can long hold on each element to open up a settings page in which they can modify any attribute as necessary. The user is able to confirm these changes or delete any unwanted passwords from the pop-up menu. Users are then able to add as many passwords securely to the device as deemed necessary. Another key feature of this application is that all the data added to it is automatically saved to the device itself, so users don't have to worry about the device memory not saving if the application is removed from the device background, as shown here. Now we can get into the NFC part of the application. On the simulator, we can select a mailbox to open by typing in the mailbox followed by the mailbox number. Once a mailbox is selected, it is ready to receive a password from the device application. In order to load a key into the NFC device to send to the mailbox, we can then select the title in the list and be presented with a screen that reads "Hold device" near the NFC reader. This ensures that the device is ready as well. Now, we can hold the device itself near the NFC reader and allow the transfer to initiate, as shown here. Before we get into receiving the NFC password in the simulator, I'm going to explain our original plan for the mailbox system itself, as I talked about earlier in this video. As shown here in this graphic, the mailbox system could be universally attached to an already existing system. The NFC-capable device would be in contact with a permanent reader installed in the system. This reader would then remotely connect to each and every mailbox in the environment and subsequently open the desired user-selected mailbox with the correctly received password. A motor would have been installed that detects a signal from the centralized unit. In our case, this is a mixture of a Raspberry Pi and an Arduino unit, to open the desired mailbox. Now that we have that covered, we can move on to the simulation. Once a mailbox has been selected in the simulation, we can then again touch the device to the reader in order to initiate the transfer. The user will then be presented with one of two options after transferring the password. Either the password is correct or it is incorrect. If the password is incorrect, the user is able to retry the password by changing on the device itself or change the mailbox that they opened if it was the wrong mailbox. The user can then again try and submit another password or another mailbox. In this case, it was the wrong mailbox that was selected, and repeat the process. If the correct mailbox is selected, the user will be presented with an unlocked mailbox and greeting from the terminal simulator that indicates that the user has entered the correct password for the correct mailbox, along with a fun joke. Our original project would have been sent a signal to the desired mailbox to use the motor unlocking mechanism to unlock that mailbox, as I had explained earlier.
Let's take a deeper look at how exactly the locking mechanism works and how our hardware receives and verifies the passwords in order to open and close the lockers. Here is a physical representation of our mechanism that allows the software to open and close the lockers. What we have here is a Raspberry Pi B, a PN352 NFC reader-writer chip, as well as a solenoid lock. The Raspberry Pi has GPIO pins, which are input-output pins. We will connect our NFC reader to 5 volts on the Pi, as well as the inputs shown here. We will also connect our solenoid lock to ground, as well as a GPIO pin on the Raspberry Pi. With these connections in place, we are effectively able to send a password to the Raspberry Pi via NFC, verify the password, and send a signal to unlock the locker. You can take a deeper look at the circuit schematic detailing the connections. Multiple locks can be connected to a single Raspberry Pi and be placed in a cluster of lockers, giving the user the ability to unlock any given locker within this cluster.
As fun and exciting as this project was, it was a completely new challenge to our whole group. Working on the app using NFC libraries and packages were a completely new challenge to learn and implement. Raspberry Pi also had its own learning curve that we had to overcome. Originally, our project was to create a mailbox that uses passwords sent via NFC to unlock. Before Rutgers had its evacuation due to the COVID-19 virus, we had understood how to create an NFC connection within the app, had received parts for the circuit, and had been using wood to start designing our mailbox prototype. Afterwards, all the parts were scattered among group members and we were confused on how to approach the project moving forward. Therefore, we decided to finish the app and show a working desktop simulation of the original mailbox idea. The main parts required for this project include an Android phone with NFC connection, a Raspberry Pi which was roughly $40, an NFC reader which was roughly $40, and we used 6 solenoid push-pull switches which were roughly $13 each. Together, this is a very expensive ensemble. This project itself is meant to be a proof of concept, a POC, so we mainly focused on its implementation. But moving forward, cost efficiency is a key factor. Some ideas we have are to use Arduino rather than Raspberry Pi, which are much cheaper. We can also use an RC522 RFID chip instead of using the PN532 NFC chip, as both are radio frequency based and can be used to read NFC signals as well, which is also at a cost of less than $5. In conclusion, we wanted our capstone project to be a proof of concept. The idea we have demonstrated is very applicable in everyday use. We envision using NFC to unlock everyday items such as doors, cars, mailboxes, etc. Being able to replace the use of physical keys with the idea of sending digital keys via NFC is the essence of our project.